Hi, today we are diving into the fascinating world of payment gateways. These are the systems behind every online payment you make, whether you are purchasing anything from an e commerce site or you are subscribing to a service. To make things simple, let's think about a payment gateway as a virtual card machine on a website. Just like a physical card machine in a store processes your payment, a payment gateway handles online transactions. Examples of popular gateways are Stripe and Razorpay, which let merchants like online stores accept payments from customers easily without dealing with multiple payment processors. So, starting with requirements, as a scope of our video, we will consider these important requirements. Uh, the main functional requirements are, let's say, number one, allow customers to make payments for goods and services. The second requirement is enable merchants to receive these payments. And the third one is customers should also be able to store their card details securely for future purchases. Beyond just functional requirements, we have some critical non-functional requirements as well for the payment gateways. So we should consider those as well. The first one is reliability and fault tolerance. Because payment gateways are essential for business, they need to handle any issues smoothly so customers aren't inconvenienced. Reconciliation, the payment gateway should track and match all payments made by customers with the payments merchants receive. The third one is idempotency and security. This ensures that if a payment request is accidentally repeated, only one processes it processes only once, avoiding duplicate charges. And also, since customer data is highly sensitive, security is paramount to protect it for any unauthorized access. Now, if we think a basic flow of how a payment gateway works, it is something like this. First, a customer enters their card details on the merchant's website. The merchant's website then sends these details to a payment gateway, where they are formatted and sent to the payment processor. Next, the payment processor forwards the details to the issuing bank. Issuing bank is the bank that issued customer's credit card. Then the issuing bank checks the card details, verifies available funds, and then sends a response back to the payment processor, which in turn sends this response back to the payment gateway. Finally, the payment gateway sends this response to the merchant's website, letting them know if the transaction was successful or not. This flow might seem simple, right? But there's more happening under the hood. The transaction process includes authorization or verifying details and settlement as well, that is, moving funds from customer's account to the merchant's bank. Now, with payment gateways in distributed systems, maintaining all of these requirements can be tricky, especially under CAP theorem, which tells us that achieving both high availability and strict consistency at the same time can be impossible. So, for payment gateway, consistency is more crucial to ensure accurate transactions. Now, when it comes to storing sensitive data like card details, obviously we need to be careful. Instead of storing card numbers, which can be risky, we use a process called tokenization. So, tokenization replaces card details with a unique identifier or token. So, when a customer enters their credit card details, the payment gateway gets a token from the card network like Visa, MasterCard, like Visa or MasterCard. It stores this token and uses it to process future payments without having to store the actual card details. Now, to keep track of all these transactions, a system must have two important tables. First one is transaction table and the second one is ledger table. So transaction table holds basic transaction details like, let's say, user ID, merchant ID, card ID, amount, type, status, created at, updated at, and so on. There can be many more as well, like let's say currency and so on. Next is ledger table. So ledger table handle more complex accounting, which use a calculation method mostly used by accountants called double entry bookkeeping, where each transaction is recorded with a debit and credit, which helps us keep accounts balanced and simplifies reconciliation. making it easier to trace every amount paid by customer and received by merchant. Now let's look at the high-level architecture of a payment gateway. So when a customer clicks pay on the merchant's site, the request is then sent to the payment gateway's load balancer, which distributes the traffic across multiple servers. The payment gateway application generates a unique transaction ID and records it in the database along with other metadata. Transaction details and then are then sent to a message queue, which the payment processor reads to reconnect with the issuing bank. Now these issuing bank confirms, and if the transaction is successful or not, the application server updates the database and notifies the merchant's website to show a success message to the customer. Now, what if something goes wrong? Payment gateways have to be ready for failures, right, and handle them smoothly. So we'll use an error queue. If an error occurs, the transaction can be retried through error worker via error queue after a set interval, and we might even use something like exponential backoff algorithm to delay these retries further if needed. Now, if repeated attempts fail, the transaction goes to a dead letter queue for manual review, ensuring it doesn't disrupt the rest of the system. So building a payment gateway requires balancing several requirements: accuracy, security, and reliability. Each component, from let's say handling customer card details to securely communicating with banks, plays a crucial role in ensuring a seamless experience for both customers and merchants. So yeah, that's it. See you in the next video.